Hi students, in this video I'll be going through the 2023 O-Level A Math Paper 1 question. Alright, so let's read the question. So we're asked to find the value of the constant c such that the line y equals to 2x plus c is tangent to the curve y equals to x squared plus 3x plus 1. Okay, so over here in this question, okay, we have a quadratic curve. Okay, so this one is y equals to x squared plus 3x plus 1. Okay, then we have a line with a positive gradient. Okay, and they say that it's tangent to the curve. So if you recall, if a line is tangent to the curve, then the line should only touch the curve at one point. Okay, so it may look something like this. Okay, so it will touch the curve at only this one point. So this line is y equals to 2x plus c. Alright, so when you have a case whereby a line is tangent to a curve, if we try to equate the equation of the curve and the equation of the line together, and then after that we try to solve, we should expect only one solution. Okay, so we should only expect one solution. Okay, so let's go ahead and then try to equate the line and the curve, and then after that we will see how we can proceed from there. Okay, so let's write y equals to 2x plus c. Okay, so let's call this equation 1. Okay, then the equation of the curve y equals to x squared plus 3x plus 1. Okay, let's call this equation 2. Okay, so let's equate 1 and 2 together. Okay, equate 1 and 2. Okay, so very simply we will get x squared plus 3x plus 1 equals to 2x plus c. Okay, so over here I've put the equation of the curve on the left side and equation of the line on the right side. Okay, so if we want to solve a quadratic equation, we've got to bring everything to the left side. Okay, then the right side will be 0. So we will have x squared. Okay, 3x minus 2x, you will get just plus x. Then after that, you will have a 1 minus c equals to 0. Okay, so at this point in time, we need to ask ourselves, okay, how many solutions are we going to expect? Okay, one solution, right? Okay, so in other words, in terms of a quadratic equation, how many real roots will we be expecting to have? Okay, we should only expect one answer, right? Okay, so this one is a case whereby we have real and equal roots. Okay, real and equal roots. Okay, so if you recall, for a general quadratic equation, ax squared plus bx plus c equals to 0. Okay, if we want, let's say real and equal roots, okay? So just some recap, real and equal roots. Okay, so what should we expect from the discriminant? B squared minus 4ac. Okay, we should expect it to be equals to 0. Okay, so okay, let's explore other cases. If we want real and distinct roots, okay, real and distinct roots. Okay, then we should expect b squared minus 4ac to be greater than 0, right? Then the last one would, if we expect no real roots, okay, no real roots meaning that the line and curve do not intersect, then we should expect b squared minus 4ac to be less than 0. Okay, so for this particular question, we will be using case number 1. Okay, so where we have real and equal roots, because we will be expecting only one answer. All right, so let's write a statement first. So if the line is tangent to the curve, okay, so the above equation, okay, above equation I'm referring to this one, okay, the quadratic equation. Above equation will have real and equal roots. All right. Okay, so if real and equal roots means b squared minus 4ac, the discriminant, okay, will be equals to 0. Okay, will be equals to 0. Okay, so then let's plug in the b squared minus 4ac. So b is the coefficient of x, so in this case b will be 1. Okay, so 1 squared minus 4. Okay, a is the coefficient of x squared, so in this case a is 1 also. 4a, and then c will be this whole thing, the constant value behind. Okay, so in this case, c is equals to 1 minus c lah. Okay, so 1 minus c equals to 0. Okay, so all we need to do is solve this simple equation, and then we'll be done. Okay, so 1 minus, okay, negative 4 times 1, it will be negative 4. Negative 4 times negative c plus 4c will be equals to 0. Okay, so bring the 4 over and 1 over, so you get 3. So c will be 3/4. Okay, so this is the answer for this particular question. Okay, so in this case, the equation of the curve is y equals to x squared plus 3x plus 1. The equation of the line is y equals to 2x plus 3/4 in order for the line to be tangent to the curve. Okay, so I'm going to put these values inside decimals, and then we can see for ourselves, right? So I'm going to share with you this decimals. Okay, so over here you can see in the red color curve, okay, it's the x squared plus 3x plus 1. So the quadratic equation in this question. And then just now we got c equals to 3/4, right? So now the blue line is the line y equals to 2x plus 3/4. So over here you can see, if I zoom inside, so you can see that the line is tangent to the curve. Okay, that means it touched the curve at only one point. Okay, if I'm going to change this c to any other value, you see this will not be the case anymore. Okay, see, when I change the c to a value like 3, then in this case the line will cut the curve at 2 points, so it will no longer be a real and equal root. So it's now real and distinct roots. Okay, so maybe you can change to other values like maybe negative 3. So if I change to negative 3, you see the line and the curve will not touch each other now, will not intersect. So this is a case of no real roots. Right? So this is how this question works. Right?